Hi, everybody, and welcome back to another SAE Government Technologies LinkedIn Live event. My name is Mark Pickett, and I am the Technology Transfer Program Manager here at SAE Government Technologies. For those of you who don't know, SAE Government Technologies collaborates with government, industry, and academia to solve the toughest mobility technical challenges. I'm excited to be here today with Kris Houghton, the Chief Operating Officer for Pratt Miller, based in New Hudson, Michigan. Today, we're talking about electrification and energy storage. Specifically, we're discussing technical challenges and barriers to adoption. I want to welcome the audience to the program today. And just as a side note to the audience, if you have questions, please use the comments section and we'll make sure to address those questions at the end of the event. Welcome, Kris. We met while you were leading the defense team there at Pratt Miller, and now you're the Chief Operating Officer. So please tell us about your role and what you do at Pratt Miller.
Thanks, Mark. Thanks for having me. I'm happy to be here. Kris Houghton, Chief Operating Officer of Pratt Miller. As Mark said, we're located here in New Hudson, Michigan, in Metro Detroit. And we help our customers transform what's possible in our three business units of motorsports, defense, and mobility. In my role as Chief Operating Officer, I oversee operations of the company overall, and I've had the opportunity to work in all the areas of the company in the 15 years that I've been here. Pratt Miller really specializes in advanced product development, and through that, we've had an opportunity to work on many different types of vehicle engineering projects across defense and motorsports and mobility, which includes commercial truck and automotive, in the electrification space and many other areas of the vehicle design and development. And most recently, in the last 3 years, we've become part of Oshkosh Corporation. So we're now a wholly owned subsidiary of Oshkosh, and all of their great brands of Oshkosh Defense Vehicles, JLG, Access Lifts, Pierce Fire Trucks, McNeilus Refuse Vehicles, and many, many more. That gives us some additional insight and experience into some of those vehicle applications and challenges in electrification and energy storage.
Awesome. Thanks for that, Kris. That's a powerful capabilities portfolio. Pratt Miller by itself, but then also combined with the Oshkosh group of companies is fantastic. Could you give the audience a sense of how broad your aperture is or scope is in the mobility space? What does mobility mean to Pratt Miller?
Yeah, for us, mobility is basically all things that move. So for us, that includes a lot of work in the automotive space and commercial truck space, but it also explores into power sports, agriculture, mining, even space vehicles and other areas of mobility as we look at the new frontiers of robotics and unmanned vehicles and all of the possibilities that are opened up by autonomy.
Thank you. I'm wondering if are electric vehicles and energy storage relevant across all the Pratt Miller business units to include racing?
They really are. What has happened in racing is a lot of hybridization. So all of the top series at this point, Formula One, IndyCar, and the top series of sports car racing and GTP all have some kind of hybrid powertrain with very interesting impacts in drivers and strategy application of energy storage and how they deploy that on a lap and how that enables them to make a pass or defend a pass. There are several full vehicle or full electric series also that are running in Formula E and the off-road series. So there is more and more coming in terms of electrification. There's demonstration vehicles being built with hydrogen and other range extension energy storage options. So there's a lot going on in the motorsports space around electrification, and definitely everywhere else that we work on vehicles, there is always an application where electrification makes sense.
You know, as I think about those three different units, racing, mobility, and defense, in the context of electrified platforms and energy storage and alternative fuels, they seem to have different levels of maturity. I think you touched upon it a little bit. We spoke the other day and we were talking about the commercial space and the fact that a lot of the automakers are very mature in their platforms and their development. So you may have fewer engineering service projects with that group of customers, but in other places like defense, where it's very early in the adoption phase, especially with tactical vehicles. Can you speak to that a little bit?
Yeah, absolutely. I think, it's obviously well known that automotive has made a huge push into EV. I think there are some other barriers and challenges in defense as you look at the infrastructure and really the implications of not having power. Certainly, there are potential safety implications to light commercial vehicle running out of charge, but the implications in the defense environment, could be much more severe than that and life-threatening. So there's low tolerance for running out of power or having range challenges because of the needing to be prepared for whatever you may need to face with an adversary in terms of defense. So that really introduces a different environment of what are the right applications for defense from a support standpoint, from hybridization, from other range extension technologies that allow you to never run out of power in a defense application. That changes a bit of the risk profile and really the requirement set for defense versus what you may look at for a full EV in the commercial or light vehicle space.
Yeah, there's no timeouts on the battlefield to charge the fleet for sure. So let's talk about the commercial space for a second and talk about some of those challenges. Range anxiety and availability of effective charging stations obviously is a hot topic. Can you, from your perspective, can you speak to that?
Yeah, I mean, I think that still remains a challenge. I think it really also introduces some other opportunities for range extension and what are some clean alternatives for range extension. Certainly, hybrids are still extremely popular and extremely valuable relative to an ICE engine hybrid, but there's a lot of hydrogen fuel cell development going on that provides some additional opportunities for clean options for generating more power and having range extension.
Good. As you look at those alternative architectures, I'll say, in terms of hybrid or range extension, I think there is some level of challenge with respect to cost. Although the cost of electric vehicles have come down recently, I think as you build and insert these new technologies along the pathway of modernization, it's probably putting more cost into the vehicle. I know you're not selling vehicles, but certainly you're contributing to tech. Can you speak on the cost barrier?
Yeah, I think, fundamentally the challenge of having two different types of powertrains is in there is that you have two different types of powertrains in there, and you have all the cost and complexity and maintenance that goes along with that. I think that is certainly going to remain a challenge. So there needs to be the vehicle requirements and total cost of ownership benefit to maintain two different powertrains, or an electric powertrain plus some version of a range extension powertrain also. Fortunately, not both of those need to deliver power to the actual wheels. So that's just a portion of the motive unit, the powertrain unit itself. But I think that continues to be one of the largest advantages to a full EV vehicle as we get past some of the power density issues and range issues and battery costs and power electronic cost specific issues. There certainly is a long-term advantage to having just a singular one powertrain to drive the vehicle, which is, really some of the fundamental benefit of EV long term.
Yeah, thanks for that. We're on the eve of SAE's International Convec. It's a symposium that occurs next week in Schaumburg, Illinois, the 10th through the 12th of September. Can you speak a little bit more detail about what's going on in the commercial vehicle space with respect to electrified platforms and energy storage?
Yeah, I think it really, what we see from our experiences, it really comes down to duty cycle. There are some very attractive full EV duty cycles that exist, where you're running a refuse truck through a defined daily route, where you do have the opportunity to not only recover a lot of energy through the stopping, regenerative braking part of that cycle, but you also have the opportunity to maximize the advantage of the electric powertrain's efficiency to get the mass moving from a start, and all of that low speed start stop, where the EVs really can provide a significant fuel economy or range, power utilization advantage. So there are those types of cycles. Oshkosh has the award for the next generation delivery vehicle, which is the new postal truck that'll be coming out. And the portion of that fleet, some 70% of that fleet is going to be battery electric vehicles, and that really is an ideal duty cycle where it's defined, it's known each day, and you return back to a home base where you can facilitate the charging. So I think that portion of commercial, there's a lot of opportunity in those known routes, in probably last mile delivery and that type of space. Once you get into longer distances and over the road trucking type, that's when some kind of hybrid powertrain really makes a lot of sense. Locomotives have been hybrid for a very long time. And I think there's lots of applications of hybrid possibilities for those longer haul duty cycles, from an ICE engine to a hydrogen fuel cell, and other things that are being invented right now.
Thanks for that, Kris. Appreciate that perspective. What about, I think you mentioned mining earlier in the program. Where's that at in its maturity and adoption, and what are some of the use cases for that? I mean, you could think of elevation changes and opportunities to recapture energy, but you're the expert.
Yeah, I think there is a lot of opportunity in mining. We don't claim to be full experts in that, but the other unique use case of mining is oxygen depleted environments. So as you go, deeper into a mine, there are cases where, and there's potential advantages to having pathways that don't necessarily have oxygen that an ICE engine would need to run. So there's certainly an advantage there from an EV powertrain, unmanned, autonomous. There's a lot of advanced technology opportunities that can really change how some of that mining work's done. And then I think, similar to some of the other commercial vehicle applications, the duty cycle analysis does show some of those duty cycles are advantageous and fairly repeatable and known, at least in an environment for a certain amount of time, that do lend themselves to consideration of electrification for sure.
Right. Can you speak to any specific projects that aren't bound by confidentiality, things that maybe are more public, to kind of demonstrate to the audience the kind of work that you're doing in this space? Yeah,
I mentioned the Oshkosh NGDV as a commercial application of a battery electric vehicle. I think there is other projects in Oshkosh right now where there's a a fully electric refuse collection vehicle. There's a hybrid Volterra fire truck that does have the option to have a diesel engine for additional power, but can also get to and from an emergency location on electric power in an electric fire truck. There are a lot of robotic applications that we're also doing right now. We have a all electric robot that is actually in the, I guess, opposite the Pratt Miller, are two all electric training assets. So these are electric robots that are intended to go on a range to train soldiers in live fire exercises, so to help with marksmanship and to enhance the training environment in reality with actually some moving targets that can change behavior and can be adapted by the trainer to change the training environment and experience for the soldiers that are getting trained in order to get them more ready for a battle situation. But that is an all-electric robot, obviously unmanned, armored to make sure that it survives any errant shots, and also has a duty cycle where at the end of the training day can be recharged and ready for the next day. So that's a bespoke custom architecture that was made into that robot to meet that training need. But that's the type of clean sheet application that we're working on for different customers and different applications in several different robotic vehicles.
Very interesting application. I probably would be one of the people that would shoot the wrong part of the robot. So there's that. I want to switch gears a little bit here. Before I do, I want to remind the audience to put your questions in the comment section, and we'll get to those at the end of the program. I do see a couple coming in, so thanks for that. SAE Government Technologies has a program called SCORE. It's a consortium, supply chain of recovered elements, and the mission of that effort really is to create fully capable domestic supply chains of rare earth elements or critical elements and minerals that are important to national security. For example, those items that are controlled by adversarial nations, we need to create some sources in the U.S. and we're not all that enamored with digging holes in the earth and creating new mines. So we have to be creative about that. So supply chain risk is a real challenge as adoption elevates, as we transition from ICE to EVs. More and more batteries are being produced, and therefore more and more raw materials are required. I know you don't really operate in that space in terms of supply chain management, but certainly it's a relevant topic. Do you have any perspective on that?
No, definitely. I think we see several different supply chain related challenges. One of them would be around volume. Fundamentally, I think light vehicle volumes are generally substantial enough to justify some significant investment in design and development. Outside of the light vehicle volumes, when you talk about a lot of the commercial applications as well as a lot of the defense applications, the volumes are much, much lower. Even if something does make it to production, the volumes are lower. So at the prototyping level, when you're working on optimization of packaging and definition of requirements, there continues to be some challenges with finding the right sized and spec'd component to meet the specific application and fit the packaging and really be the right size and space claim and architecture to fit the needs of a new application. But even when some of those defense or most of those defense and commercial applications go to production, there is not the enormous product development budgets that a light vehicle would have that that allow you to do a lot of the individualized validation and verification of that vehicle's components and architecture. So that becomes a challenge from a business case standpoint to be able to have the right package and functionality, but be able to afford the validation that's required for what is relatively still newer systems around batteries, power distribution units, and other components necessary for the EVs.
Thanks, Kris. And I think also another topic that's adjacent to supply chain is recycling. So SAE International has a Sustainable Mobility Solutions group led by Frank Menchaca, very much involved in EVs and energy storage. And one of the focus areas is cradle to cradle with respect to batteries for EVs. From a design and engineering perspective, are there things that we can do on the front end that don't jeopardize performance but aid in the recycling post use?
Yeah, I am sure that there are. I think there's still a lot of movement just in chemistry, in voltage, in packaging, in a lot of the elements that go into what the actual battery is. And I think that standardization of that over time and how that happens and still enables the companies to be competitive in the market to balance out, I think is going to be a key factor in just eliminating the number of variations and formats that batteries and their components come in that are just going to make it more, as that proliferates, that just makes the challenge of what are the recycling options, it's just going to continue to expand the number of considerations that need to go into recycling the different product that's in everything across all the markets.
Exactly. You mentioned packaging. There are form factors in cell technology. You mentioned chemistries. When we were talking about supply chain risks, probably another topic that's important from a technical standpoint is power electronics and battery management systems. And can you talk about maybe some of the work you've done with power distribution units?
Yeah, I think we do see, as we're often working on new vehicle types, we do see limitations in the standard products that are available. So I think the same challenge that I spoke to relative to fully validating a low volume system and having that business case work out, I think that also applies to the supply base as they look at how do they be a viable supplier across so many different applications of electronic components. And what that ends up doing is it just limits the number of mature components that are available to go into advanced product development that are on a path to readiness for production. What that's meant for us is that we've worked on a lot of our own modular designs. So in a lot of this space, it's as this audience knows, it's a combination of hardware and software that makes things work. You have the battery and you have the battery management system, which is a combination of hardware and software that controls that system. So I think we've been able to develop both hardware building blocks and software building blocks that allow us to scale up and down packaging sizes, capacity, power ranges, voltage ranges. That does provide some basic fundamental validation and past experience that we can build off from and apply to other platforms and scale it across different applications. We've been fairly successful with that, and we're moving that into some PDU product availability that we're starting to offer.
Well, I'd be remiss if I didn't put in a shameless plug as a standards development organization, but can you speak to what role standards play, whether it's SAE or ISO or others, as a development team, a strong engineering team, how do you rely on those?
Yeah, I would say there is a lot of both physical and then architectural configurations that are very dependent on the standards, from what are we going to use for charging interfaces to what are the standard connectors, and is that hardware available? Is it truly standardized? I think all of those things are enablers to reduce the barriers of implementation and actually getting these technologies into production. So we rely on it heavily to try to reduce the number of options that we have while still having the flexibility to meet the specific requirements of the product that we're working on.
Thanks, Kris. Appreciate that. I think we touched on it earlier, but I just want to make sure we cover it, because I do think there are some nuances between the commercial and defense space, and obviously you and I work quite a bit on the defense side. Can you speak to that maybe at a high level, just some of the differences that you see?
Yeah, I think one of the biggest differences that we see is the volumes, like I already mentioned. I mean, generally, the applications are just much smaller volume, and that brings with it the challenges I've already mentioned relative to how do you validate and ensure that you can meet all the requirements. I'd say from a requirements standpoint, the standards are different when we're working to MIL standards than an ISO 262 type standard, but they have a similar, functional safety approach to that requires a similar development path to bring something to maturity and production. We're working a lot in TRL levels, which is a bit different scale than you'd use in the commercial environment, where you're working on TRLs and MRLs for technology readiness level and manufacturing readiness level, all still along the standard philosophy of product development and maturation and eliminating risk and getting ready for that product to work in an error-free way in its intended environment. So that's certainly, there is some differences there. I think, it's not, there's a lot of work going on right now in the DoD to reduce product cycle time. The DoD certainly has a history of taking, 2 to 3 times longer than automotive to make it through a product cycle. Something that is 2.5 to 4 years in automotive ends up being 10 to 15 years in defense to turn a vehicle, complete vehicle from the beginning of requirements development to actual getting it to the warfighter. Certainly in times of conflict, we've proven as a American industrial base to do much better than that. But that typically, I think there's a big push, it typically is a lot longer in defense. And that's something that the Defense Department is not unaware of, and they are definitely working on how do they engage organizations like SAE and others to help speed that up.
Yeah, for sure. And those military platforms has to last forever, right? 25 years is not uncommon. And if you have a vehicle 25 years in the automotive space, it's a historic vehicle. So there's that. On that, as a follow-up, a question from the audience: do you see the momentum of EV adoption in the U.S. dropping with recent moves by the big automakers?
Yeah, from my perspective, I think there's still the infrastructure catch-up that's needed to make American users comfortable with the range and the charging. So I think there's been the typical early adopter spike and cycle that is true for all new product development that's happened with EVs. I do think that there certainly was an enormous push to go 100% EV by many of the manufacturers that is being scaled back a little bit. I think largely due to having the consumers voting with their dollars and saying they're not quite ready for that full commitment to 100% EV, and that I think the infrastructure is going to need to catch up a bit until there's a higher comfort level across the board to hit some of the original EV volume projections. But that's just my take on it right now.
Thanks, Kris. There's another question. I think we touched upon it earlier in the program, but I think it's worth reading again now. What is Pratt Miller doing to improve electric vehicle ranges?
Yes, so I think there's a lot specifically to the electronic architecture and electronic components that relate to ranges. Certainly, higher voltage and higher efficiency from that. But there's a lot of other vehicle systems that we look at in terms of a full energy analysis. So when we look at what are all the energy losses in a vehicle, there's tire rolling resistance, there's driveline drag, there's parasitic losses in other components. And then as speeds increase, aerodynamics becomes the largest loss. So we do an enormous amount of aerodynamic work. The picture above my head is actually some commercial truck scale model wind tunnel work that we were doing with wind shear in the Carolinas on test methodology, aerodynamics for over-the-road tractors and trailers to really reduce that aerodynamic drag as the single largest loss at the higher speeds. So really, from our, we approach it from a full vehicle standpoint and look at all the sources of losses in addition to what specifically can be done with the electrical architecture right from the beginning when you're designing, what voltage level are we going to work at, what motor type are we selecting and why, how efficient are all of the other electronic losses. Those, in the end, need to be balanced and worked on with the full vehicle system, because there's many of the systems on the full vehicle that actually have as big or bigger contributions to the overall vehicle performance in terms of range.
Thanks, Kris. This question popped up while you were answering that question, and it's how are digital engineering tools used today, and how important are they in developing electric vehicle architectures?
Yeah, so they are used extensively. At least in our programs, we're doing full system models for every system of the vehicle. So all of those losses that I talked about are things that are modeled from a mass inertia standpoint, tires from a rolling resistance standpoint, overall vehicle from an aerodynamic standpoint with CFD, but also from a electronic architecture standpoint, and then the specific control software I mentioned earlier. A lot of the EV systems are a combination of hardware and software. So all of that software can be written in model-based code and then used for simulation with the same algorithms that are going to be used to control the vehicle subsystems, can be used in full vehicle modeling to predict the performance and optimize that performance before any hardware is built at all. And then the really cool thing about that is that can continue on to add the actual software in the loop, the actual hardware in the loop before you get to the full vehicle testing, which really enables a faster validation cycle for the full vehicle.
Thanks, Kris. Here's a question. What are your concerns about high voltage and safety?
Yeah, that's a great point. It is Mark and I did talk about this a little bit earlier. I think, for us, the introduction of high voltage was, I would say, it was another chapter in our safety journey. So it did require us to get smart on, what additional equipment do we need relative to protective gloves, insulated tools, emergency removal, separation tools for personnel away from high voltage area, the markings, the lights required to say that a high voltage system is active. But over time, that's just become standard operating procedure for us. Now we train our whole team, any team that's going to be either engineering or working in the shop around high voltage goes through a high voltage training program for us. And it's really just it's a supplement to the safety training we are already doing, but it does require a specific concerted effort around high voltage to make sure you're keeping your employees safe and that you have the equipment that's necessary to work on the high voltage systems and to react to anything that might happen in an emergency situation relative to high voltage.
Great. I've been to your facility several times, and I can tell the audience that safety is number one, not only at Pratt Miller, but also Oshkosh. That's been my experience. Here's a question, and I'm not sure about the answer. It's what are the connections to aerospace on your work?
So we do some aerospace work. We have done some work, especially in the space area. We've had some product and some parts that have gone into the International Space Station, and we have our robotics chief engineer is a former NASA engineer with connections in that area. So it's not a huge market focus for us. The other place that we run into aerospace is just in quality certifications. A lot of the defense work, utilizes the aerospace quality certification. So that's the other kind of area that we bump into aerospace without working in it directly, is just the quality requirements required by many of the defense projects that we have.
Thanks, Kris. And Sherry, from my perspective, SAE is very much involved in the aerospace and has a significant footprint. And so, Charlie, if you would put up my email address on the screen, if it's handy. If you have specific questions, I can direct you to the specific committees and task forces that might be working on electrified systems and aerospace applications. So, Kris, I think we're out of questions from the audience, and I think we're bumping up against probably a good amount of time for our LinkedIn Live event today. I want to thank you again for your participation. Always a joy talking with you, nerding out on technical topics and talking about family or whatever at trade shows. I have tremendous respect for you and your team. You guys do amazing work, and I look forward to collaborating with you for years to come. So thanks again. I want to thank Charlie and Tracy for supporting us technically behind the scenes. I think today was a wonderful live event, and I look forward to doing more in the future. Thanks, Kris.
Thank you, Mark. Thanks for the opportunity.
You bet. Have a good afternoon.
Thanks.